For our Unit 1 quiz, we start with number 1, simplifying the expression. We're going to distribute first. We get 2x plus 6 for our first expressions, and then we have minus an 8x squared plus 20x. We're now going to subtract this from our original, so I'm just going to distribute the negative. 2x, 6, negative 8x squared, and negative 20x. So I have negative 8x squared as my lead term. 2x and negative 20x gives me negative 18x, and then the 6 at the end. For number 2, I'm first going to multiply x plus 1 times x plus 1. And if I multiply that, or really just square it, I get x squared, x, and 1. So it's x squared plus 2x plus 1. So now I'm going to multiply what I had, my new product, times my other term. So for this, we get 3x to the 4th, 6x cubed, 3x squared, an x squared, a 2x, and a 1. Now you gotta be careful, these are not like terms. I actually have a 3x squared and an x squared here, but it's gonna become 3x to the 4th plus 6x to the 3rd plus 4x squared plus 2x plus 1 as our answer. Now for number 3, I could go through and multiply these two and then the third one, but I'm going to look at these two terms here. These are a difference of two squares, so when it's x plus 2 times x minus 2, that becomes x squared minus 4. And it really just kind of saves me extra time getting to that. Now I'm going to multiply x squared minus 4 times x plus 1. I get x to the 3rd, negative 4x, x squared, and negative 4. I don't have any like terms, but I have x cubed plus x squared minus 4x minus 4. For number 4, we need to find the area of the shaded region. Now, I have the area of this big rectangle, and that's going to be 2x minus 6 times x plus 2. I'm going to subtract from that the area of the triangle. Now, the triangle is x plus 2 is its height. Its base is half of the 2x minus 6 because we have the congruence markings, so that's going to be x minus 3. And then for area of a triangle, we divide that by 2. So we have a few different things that we're working with here. Let's first multiply this. 2x minus 6 times x plus 2. Comes out to be 2x squared minus 2x minus 12. And now x plus 2 times x minus 3 is x squared minus x minus 6. Now all of that is over 2. Really these are coefficients. So it's really like saying 1x squared minus 1x minus 6. I'm just going to take half of each of those. So this becomes 1/2 x squared minus 1/2 x minus 3. So that's being subtracted from the 2x squared minus 2x minus 12. So I have 2x squared minus 1/2 x. That's going to be 1/2. 2 minus 1/2. So we could say that's 3 over 2 x squared. Negative 2x minus a negative 1/2 x is like saying negative 2 plus 1/2. So that's going to be minus 3/2 x. And then negative 12 minus negative 3. If we just distributed, we see that's almost like negative 12 plus 3, so we get minus 9. So the area of our shaded region is 3/2 x squared minus 3/2 x minus 9. For number 5, we're going to factor. Here I have common factors. I can take a 2 and let's see, it looks like an x and a y out. That leaves me with x squared minus y squared. And we don't stop there. We can actually keep going because this is a difference of two squares. And this is 2xy, x minus y, x plus y. Anytime we have a square minus a square, we can factor that. For number 6, I'm going to factor out a 2 first. And I have 16 a squared plus 8ac plus c squared. This I could factor by looking at multiplying to 16 that adds to 8. In that case, we could do like 4 and 4. So we could break that into two terms, factor by grouping, but what I also see here is a pattern. This is a square, this is a square. So actually by factor by grouping, this turns out to be 4a plus c and 4a plus c. This is a pattern that happens when you square a binomial, which turns out to be 2 times 4a plus c squared. For number 7, we're going to factor by grouping because we have 4 terms. If you get 4 terms, factor by grouping. So I'm going to take out a 2, and I get x squared minus 1. I'm going to take out a y, and I get x squared minus 1. This is in both terms, so I take that out. I'm left with 2 plus y. Now, this is a difference of 2 squares. I can simplify that. So I get x minus 1, x plus 1, bring the other one down, 2 plus y. For number 8, I want to think of this first as, what if it was just something like x squared minus 5x plus 6? If it was something like that, I would say, all right, multiply to 6. That adds to negative 5. How about like negative 2 and negative 3? And I would make it x minus 2, x minus 3. It's the same idea here, but instead of x, I have y's, and it's y to the 4th. So what I'm going to end up with is y squared and y squared. So it's going to be y squared minus 2, y squared minus 3. Now, what I'm not going to have to do here is worry about a difference of squares, because 2 and 3 are not perfect squares. Leaving it there is perfectly acceptable, and it is factored down. For number 9, 4 terms, so we're going to go factor by grouping. I can take out an x squared from the first 2 terms, and I get x to the 6th minus y to the 6th. I can take out a y squared. From the next 2, I get x to the 6th minus y to the 6th. So it's x squared plus y squared, and x to the 6th minus y to the 6th. Now from here, we actually have 2 options on how to solve it. One way is to think of this as a difference of squares. The other way is to think of it as cubes, and I'm going to show you both. So if I went difference of squares here, this would become x cubed minus y cubed, x cubed plus y cubed. And that's saying taking half of the 6, so it's this difference of squares like we had on problems like number 5. Okay, now if I did that, I then have to simplify this as cubes. So this one becomes the first term minus the second. Then it's the first term squared. We go both terms, last term squared. And we go same sign, opposite sign, always positive. And then we factor the x cubed plus y cubed, and that is x plus y. Then it's going to be x squared, xy, y squared, and then we go opposite sign, same sign. Bring down the x squared plus y squared, and this is our whole answer. Now that's if we go difference of squares. If we just treat this as cubes, then this becomes x squared minus y squared, x to the 4th, x squared, y to the 4th, opposite sign, same, always positive, which this becomes x minus y, x plus y, bring x to the 4th plus, let's get another piece of paper. So we got x minus y, x plus y for my difference of 2 squares. Then bring this down, x to the 4th plus x squared plus y squared. And our original term, x squared plus y squared. So in this case, we have these 4 terms. So really our options are this statement or this one. Now if we look, this is the same, this is the same, this is the same. It's the fact that this term and this one are the differences. For right now, it's okay if we leave it there. We're good with that, and either option is where you could go. In either case, it's got a lot of factors. So number 10, a little bit nicer. Multiplies to negative 15, adds to negative 2. I'm liking negative 5 and positive 3, so I'll go w minus 5, w plus 3. For number 11, I'm multiplying to negative 8, adding to negative 7. We'll do negative 8, positive 1. So this one, I'm going to break this into a grouping problem. I'm going to break up negative 7xy. So we'll go 2x squared minus 8xy plus xy minus 4y squared. Didn't change the equation at all, just decided to split negative 7xy into these two terms because it's going to work by factor by grouping. Again, 4 terms, go to factor by grouping. I can take out a 2x and I'm left with x minus y. I can take out a, oops, that should be a 4 there. I can take out a, looks like a y, and I'm left with x minus 4y. X minus 4y is in common, and then 2x plus y is my other factor. For number 12, I'm going to factor a 3 out first. This gives me a 3g squared plus 14g plus 8. When I multiply, I then have 24 that adds to 14. So we can do 12 and 2. So I'm going to break this 14 into 12g and 2g. This gives me a factoring out of 3g. We have g plus 4. Factoring out of 2, we have g plus 4. So my factors are 3g plus 2, these two, and g plus 4. But don't forget the 3 from the beginning, and we have our factors. For 13, I'm going to multiply the front and last term, and I have 20 adds to 9. We could do 5 and 4 for that. So that's going to go 10c squared plus 5c plus 4c plus 2. I factor out a 5c and get 2c plus 1. I factor out a 2 and get 2c plus 1. 2c plus 1 is in common. Left over is 5c plus 2. Number 14, multiply to negative 36, adds to negative 5. I'm liking negative 9, positive 4. So go 12m squared minus 9m plus 4m minus 3. We factor out a 3m, I get 4m minus 3. I factor out a 1, I get 4m minus 3. So my result is 4m minus 3 and 3m plus 1. For 15, we got 4 terms. We're looking at factor by grouping, but first, I'm going to factor out a common factor, GCF. I could take out a 2 and I get m cubed minus 4m squared plus 2m minus 8. It's going to make things a little bit easier. So when I go to factor by grouping, I take an m squared out of the first two, a 2 out of the second two. Then we group and we have m minus 4 and m squared plus 2. We have a squared, but it's not a difference, so we're good. Our factors are 2, m minus 4, m squared plus 2. For number 16, we got 4 terms, factor by grouping. I'm going to take out an x squared and get x minus 1. I take out a 1, I get x minus 1. So we have x squared plus 1, x minus 1, can't reduce any further. That is our answer. For 17, I'm not going to worry about making this multiplying out. What if we just thought of x plus 3y as a blob? So this actually becomes blob squared minus 4 blob minus 12. If you don't like blob, make it a or b or some variable, because I can factor this with that out. So if I do that, this becomes multiply to negative 12, that adds to negative 4. We could do 6 and negative 2. How about negative 6, positive 2? So this becomes blob minus 6, blob plus 2. Now it's factored, put this back in, it's x plus 3y minus 6, x plus 3y plus 2 as my factors. A little bit cleaner, a little bit easier to simplify. There's my result. For 18, this is, as we're saying here, is 2a to the third. This is 3c to the third. So we're going to use our rule for cubes. So the first one is one of each term, 2a, 3c. We keep the same sign. Then we square the first, 4a squared. Use both terms, 2a and 3c is going to be 6ac. And then the last term squared is 9c squared. Same sign, opposite sign, always positive. 19 works the same way. This is 5 to the third. So we're going to go 5 plus p, then the first term squared, then we're going to go 5 and p, one of each, and then the last term squared, p squared. Same sign, opposite sign, always positive. Here's our result, kind of off screen there. 20, we got two options. This is similar to an earlier one we had, number 9. You can look back there. This, we can either make it a, think of it as cubes, where it's x to the x squared to the third and y squared to the third. So that would become, in this case, x squared minus y squared, x to the fourth plus x squared, y to the fourth. We can factor this to be a difference of two squares, x minus y, x plus y, and x to the fourth plus x squared, y squared, plus y to the fourth. The other way we could go about this problem is treating it as cubes from the beginning, or not cubes, difference of squares. That would become x to the third minus y to the third, and x to the third plus y to the third. And if that's the case, we then have to factor them as separate cubes, kind of like we just did over here. So this becomes x minus y, x squared plus xy plus y squared from here. And the positive one becomes x plus y, x squared minus xy plus y squared. Either one works the result. It's really using your factoring. I would accept either answer. 21, you need to find the area of the shaded region in factored form. So the area of the whole thing is going to be 4x squared times 8x, and we're going to subtract to that the area of x times 4x. So we get 32x to the third minus 4x squared. I can factor out a 4x squared from each, and I get 8x minus 1. That's the solution. That's the factored form. For 22, we need to solve for the value of the variables. We're going to treat it as factoring with everything to one side, and then we're going to take each of those factors and set it equal to 0. So if I go 3x squared plus 10x minus 8 equals 0, and that's by subtracting the 8 over, I'm first focused on factoring this. So this is going to be multiplied to negative 24 that adds to 10. So if we did, how about negative 2 and positive 12, we go 3x squared plus 12x minus 2x minus 8. Factor out a 3x, I get x plus 4. Factor out a negative 2, I get x plus 4. So 3x minus 2, x plus 4 are my factors, and those are equal to 0. Now what I have to do is set each of those equal to 0. 3x minus 2 equals to 0 gives me 3x equals 2, and x equals 2/3. X plus 4 equals 0 gives me x equals negative 4. So my solutions are 2/3 and negative 4. You only have to do this when the equation's equal to 0 and they want the solutions. Otherwise, the factoring, like we've done already, you would just leave it as 3x minus 2 and x plus 4. For 23, I'm going to move all the terms to one side. I'm then going to distribute and get x squared plus 4x plus 3. I can factor that now. Multiply to 3, add to 4 is going to give me x plus 3, x plus 1. So x plus 3 equals 0 gives me negative 3. and x plus 1 equals 0 gives me negative 1, so my solutions are negative 1, negative 3. For number 24, I'm going to move everything over. I have 9y squared minus 18y equals 0. I can factor out a 9y from both terms, and I'm left with y minus 2 equals 0. In that case, 9y equals 0 gives me that y equals 0. And y minus 2 equals 0 gives me that y equals 2. So my solutions are 0 and 2. Last one, we move all of our terms over. 2c to the third plus 3c squared minus 2c minus 3 equals 0. We can factor out a c squared, and I get 2c plus 3. Factor out a negative 1, 2c plus 3. This becomes c squared minus 1, 2c plus 3. And look at that, it's been a couple problems since we had a difference of 2 squares. We have to do that again. C plus 1, c minus 1, 2c plus 3. So c plus 1 equals 0 gives me that c is negative 1. C minus 1 equals 0 gives me c is 1. And 2c plus 3 equals 0. We get 2c equals negative 3. C is negative 3 over 2. So my answers are negative 1, 1, and negative 3 over 2.